So when taking a look at Z-scores, we're trying to get a representation of where do we fit according to normal or to the average. Are we above average or are we below average? And the Z-score tells you how well you're doing in relation to others when the base score or the data comes from different sources. So this goes back to our example in the previous one where we talked about how well is that 70% grade. Well, if the average in Mr. Barkman's class was like 60 and you got a 70, well, you're above average. Okay, so if you look at all the students in Mr. Barkman's class, the average was 60, you got a 70, that's above average. Way to go. Now in Mr. Danger's class, maybe the average score is like 85 and your cousin only got a 70. Well, that's way below average. Okay, and so that makes a big difference when it comes down to where you kind of stack up according to the average. Now, again, small scale averages aren't quite as reliable, but once we start dealing with a larger scale of stuff, averages really are a lot more reliable. So the Z-score is again, let's remember this, the Z-score is a number of deviations, or remember that little sigma, from the mean. How many deviations are you away from the mean? And the maximum that we're going to have is about 3.5 deviations away for the most part. If we get anything farther, then that's starting to be really skewed data. But for what we look at, we'll probably get roughly about 3.5 below and 3.5 above, and that should cover majority of people or majority of data points. So a couple things here. Z equals 0. This is the average. Okay? This is your average. That means that data point is right at average. We'll rarely do that because, well, we want to try to find what actual ones are, or do a little bit of calculations for it. If Z is greater than 0, so it's a positive number, that means that data point is above average. And if it's less than 0, that means that data point is below average. And so that's something to be, we can usually see just by the number, but this will tell us how far above and below that average something is. Okay, so let's take a look at an example. So on how you score on a test is often based on how you did according to the average. Okay, so just because you get 90% on a test doesn't really mean that you did better than an 80. If everybody did good on one test and nobody did good on the other test, an 80 could be better than a 90 when you compare. So let's take a look. Let's find the Z-score and let's use our formula to do that. So our formula for Z-score, put this in here nice and quick here, is Z is equal to X minus, and now I've got to get my little X bar here, right there, divided by sigma. Okay, there's our equation. I'm just going to put that in the middle because, well, we're going to use it for both, so we might as well, instead of having to write it out a number of times. So there's our formula. Z is equal to X minus X bar and sigma. Your data point, okay, so it's important to remember here that the data point is X. The average, I'll try to do this nice and quick here, is X bar. Where's X bar? Okay, and the deviation is sigma. Okay, so deviation is sigma. There we go. So there's our three pieces of data that we need to have if we want to find our Z-score. So let's solve for the Z-score in this case here. All right, Z is equal to 80 minus 70 divided by 5. There we go. It really is that simple. Okay, it's what mark you got minus the mean, and then we divide by 5. Now, important thing when we're doing this with our calculators, it's important to remember that we have to put brackets on the top, or we have to hit equals after we finish the top. Very important. Otherwise, it's going to give us skewed numbers. It would give us an extremely big Z-score, apparently. This would give us, what would that be, like 56? No, 66. Okay, if we did this without brackets, give us 66 on our calculators. We need to make sure that we do brackets here. So let's solve for this here. So we got brackets, 80 minus 70 divided by 5. and we get a Z-score of 2. Okay, and you can probably tell, right? Difference of 10, so 5 goes in there 2 times. So in other words, Z equals 2.00. We're always going to do 2 decimal places. It becomes a lot more important later on when we start talking about normal and percentages. So let's make sure we do 2 decimal places. We will need that later. So this one has a Z-score of 2. That means that that person is a decent amount above the average. Okay, 10% doesn't necessarily mean a lot, but depending on the deviation, 10% can be a lot. So it's 2 standard deviations above. That means that they're actually quite close to the top of the class, and we'll talk about that in later lessons. Okay. What about if you got 63.4% and the average was 71.3% with a deviation of 4.82? Sorry, I should have actually put my units on here. These are all percentages. Okay, so that's all percentages. Let's try this one here. Again, we're going to do the same thing. We're going to do Z-scores. So Z is equal to 63.4% minus 71.3% divided by 4.82%. Now you should probably be able to see in this case here that when we subtract, we're going to get a negative number, so we're going to get a negative Z-score. A negative Z-score means that we are below average, okay? And below average is okay. That's not a bad thing. Well, I shouldn't say being below average, it's just a matter of kind of figuring out where we're standing, right? It's figuring out where we're standing according to the average. 63.4%, that's still passing, right? So that's still passing, so it's not too big of a deal. Let's do this here. So 63.4 minus 71.3, close brackets, divided by 4.82. All right, now we're going to get negative 1.64. Okay, look at the decimal places. The next digit is a 9. That means we bump up. So we go to 64 instead of 63. And so our Z-score is negative 1.64. Negative 1. There we go. Negative 1.64. So this represents that we are below average in this case here. And below average means that it is farther down. Okay, now you'll notice here that this is not as far below average as this one is above average. Okay, it's not as far from the norm as the 2 is. Okay, so in this case here, that is something that we can kind of think about. It's not as far away as this one is here. Z-scores always reported to 2 decimal places. Okay, so this is very important. I know sometimes we kind of get away from that 2 decimal place thing, but here, very important that we always do 2 decimal places. Let's take a look at a second example right here. We're going to do a few more here, or a couple more here. So each year, employees get reviewed by their boss. Your review at Tim Hortons was 8.2 out of 10, and your friend at Sobeys got a 7.9 out of 10. Who's the better worker? Well, it's easy, right? 8.2, definitely a better worker. But it depends on the scale that we're looking at. Okay, the person at Tim Hortons, your boss, might give really good reports, whereas the person at Sobeys might give really bad reports. If you look here, the average at Tim Hortons was 7.5. The average at Sobeys was 7.2. Okay, that doesn't mean that Tim Hortons employees are better than Sobeys employees. That's not what it means. Okay. It's important that we understand that. It's just a matter of the scale that has been used, because it's probably 2 different people that are judging. Okay, so it's important that that scale is represented as well, and that's where Z-score comes in, because Z-score will base you on the people that are around you. Okay, it'll base you on that mean. So let's look at Tim Hortons here. We have a mean of 7.5 and a standard deviation of 0.5. And you at Tim Hortons, and we're going to say that you're at Tim Hortons here, you got an 8.2, which is, not bad. Okay, so Z is equal to 8.2 minus 7.5 over 0.5. Okay, and so Z is equal to, let's get the calculator out here, 8.2 minus 7.5 divided by 0.5. You got a Z-score of 1.4. Not bad. It's not bad. Okay, at 1.4, you're above average. You're kind of working your way up. Later on, we'll look at what percentile you're in. But for right now, 1.4, not bad. Let's see where your friend at Sobeys fit in. did they fit in the same spot? Or did they do better according to the average, or did they do worse according to the average? Okay, so let's try this one here. We got 7.2, no, sorry, 7.9 minus 7.2 divided by 0.3. Okay, so your friend at Sobeys, that equals, right here, 7.9 minus 7.2 divided by 0.3. They're at a 2.33. So according to the Z-scores, your friend did better than you did. Even though their score was less, they did better according to based on the average. So they are actually, according to the rest of the employees there, their coworkers, they are better. They're higher up, okay? Which is a different way of cataloging. And it's important that we understand that Z-scores catalog based on the norm or the average, not just in general. Okay, so it tends to kind of help balance between a tough marker and an easy marker, right? So it goes based on what you see in the class, or sorry, in a group of data.